Hello everyone, welcome back to my channel. My name is Piyush and this is day one of Azure DevOps Zero to Hero series. So I will not waste even a single minute and directly jump into the video. Alright, so I have logged into my GitHub repository which I have already shared in the previous video. If not, I will share again in this video as well. So check out the description. This video link is already there. After going over there, there are different folders for each of the day. So do not forget to check it out. Day one should have been populated by now. So if you scroll down, this is what we'll be covering as part of day one is introduction to Azure DevOps and basic concepts such as what is CI/CD, Agile, DevOps, why do we use it, what were the challenges with the traditional software development lifecycle and how DevOps solves it. And then finally, we'll be doing a quick walkthrough of Azure DevOps, how to sign up and how to create an organization, how to create an projects and so on. So let's start with the very basic. What exactly is cloud computing? Before that, we need to understand why do we actually need it. Imagine you are the owner of a small IT firm and you want to scale your business. However, you would need a large number of resources to make that expansion possible, such as office space, more hardware, more furniture, a lot of people to manage all these, and a lot of money for everything. These one time upfront expenses are also known as capex or capital expenditures. Then you would also have some recurring expenses such as cost of regular hardware maintenance, salaries to employees, electricity bills of the office, monthly building rentals, and so on. These recurring operating expenses are called OPEX or operational expenses. These are nothing but the roadblocks for this expansion, and your goal is to minimize your capex and opex and build a system that is highly scalable, highly available, and fault tolerant. A system with built in security and high performance. Enters cloud computing. Cloud computing is a way to access these computer resources and services over the internet instead of having to buy and manage it yourself. Imagine that you need to run a software program to store a large amount of files. Instead of buying that hard disk drive, you rent a storage service such as AWS S3 or Azure Storage or GCP Blob Storage, and it will provide you that access over the internet where you can store your files and make use of it remotely. So buying hardware is old school. Renting hardware is what cloud computing is all about. Now let's talk about the difference between IaaS, PaaS and SaaS. IaaS, as the name suggests, infrastructure as a service, PaaS is platform as a service, and SaaS is software as a service. IaaS gives you full control over the infrastructure resources such as your virtual machine storage. You can rent these resources from a cloud provider and configure them as needed to run your own application. Right? You install your own operating system and you configure all your custom applications. You take care of all the management tasks and administrative tasks, and you have basically the full control over your operating system and your infrastructure. But in PaaS, they will provide you a runtime environment and a platform to deploy your application and development tools. You do not get access to the underlying operating system. You get access to their environment in which you can deploy your application and start using it. In SaaS, they would provide you the application that you can consume directly as an end user. So these software applications that are hosted on cloud and run by the cloud provider. You just use them as the user. In IaaS, you must take care of all the administrative tasks such as server patching, upgrades, backups. Patching is nothing but making sure all your softwares and your operating system packages are up to date and have all the fixes of security and vulnerability. In PaaS and SaaS, Azure takes care of all your admin tasks, right? So as we said, when you need full control over your operating system, you go with IaaS. When you do not want to take care of all your admin tasks, you go with either PaaS or SaaS. IaaS models are mostly pay per use. You pay whatever service you use for a particular duration. Services such as Amazon EC2, Azure VMs, or GCP Compute Engine. PaaS models are mostly service based models such as Azure Web App. SaaS models are mostly subscription based, such as your Gmail application, your Office 365 subscription, your Dropbox. All these are SaaS application where you do not deploy anything. You just use the application, the standard version of the application. So lift and shift migration is nothing but when you have to move your applications hosted on premises to the cloud infrastructure so that you get all the benefits of cloud, but you do not want to make any changes to your application. So that is called lift and shift. IaaS would be the ideal choice because you get full control over your operating system and you can customize your application as you need. As model is again the ideal choice where you do not want to take care of your admin task or you do not need the underlying operating system access and you just want to focus on your application deployment and just start using it. SaaS model is the ideal choice when you can use the standard version of a cloud application without making any customizations. Like if you want to use a Google Workspace application such as Gmail, you just start using it. You just take the subscription and start using it. You do not deploy your own version of Gmail on top of that. You basically don't have access to do that. So SaaS is the choice in that case. Now, the next one is a shared responsibility model. Shared responsibility model is nothing but an agreement between customer and Microsoft that there are certain responsibilities that will be taken care by Microsoft. There are certain responsibilities that will be taken care by you as the customer, and some responsibilities will be shared among both of the parties. So, for example, let's say you have an on prem application. When you work on that, everything from your physical data center, from your physical network, physical host, your operating system, networking, application, everything, right? Everything is taken care by customer. That means you, or if you have hired some third party uh, organization to manage all that, right? So there is nothing that will be taken care by Microsoft or any cloud provider. When you move to IaaS, you basically do not worry about the physical infrastructure. So all the physical data center, physical network, physical host, these things will be taken care by Microsoft, and you can just focus on your operating system and rest of the things, right? Your application, your network controls, all of those things. But when you move to PaaS, yes, Microsoft manages your physical aspects of the infrastructure, but they also manages your operating system, right? So this is the main difference between IaaS and PaaS. In IaaS, your operating system is managed by you, right? In PaaS, your operating system is managed by Azure, right? And these three responsibilities, identity and directory service, like Azure Active Directory and or your applications or your networking control, these are the shared responsibilities between you and the customer. When you move to SaaS, right? So again, the physical responsibilities of the infrastructure will be taken care of Microsoft along with the operating system as it was there in PaaS. And on top of that, your application and network control will also be taken care by Microsoft. And you just have to focus on your information data, your devices from which you will be managing the application, and your accounts and identities. Like if you are configuring single sign on or OAuth authentication, or like LDAP, anything would be taken care by you only as the customer. Before we deep dive into CI CD and modern development philosophies, let's have a look at the traditional software development lifecycle and what were the issues with it. Let's say we have multiple teams working in a project, such as developer, operations team, quality assurance team, or testing team. And then we have a production support team, which usually work on the production environments. there could be much more. Multiple developers commit the code to a version control system. Once the code is committed and approved, someone from ops team would then create a build using the code base that was committed. Build is then placed to a shared folder or a network drive or on an environment. The ops team would then deploy the build to a lower environment such as quality assurance. After transferring the build to that environment, testing team is that notified and they start executing their test cases against the build. Reports are then provided to the developers and other stakeholders about the test cases. Developers would then fixes the bugs and defects and commit the code again, and this process will continue for other environments such as SIT, performance test environment. There could be hundreds of more environment. Once the change management approves the changes, someone from production support will then deploy the build to the production environment after transferring the build from other environment that was already being tested. A traditional software development lifecycle used to follow a waterfall model that usually starts with requirement gathering with all the parties involved, like pre sales team, business, customer, and all the stakeholders, followed by system designing. And then there were several developers who used to code for hours and days to implement the entire software all at once, followed by testing, wherein testing teams were performing different test cases such as performance test, integration test, smoke test, and so on. And then finally, operations team would perform the deployment on various environment, including production. And that is at this stage where your application is live and customers and end users starts using it, and then ongoing maintenance for any bug fixes or operational support that customer might need. As the name suggests, waterfall model, it depicts the features of a waterfall, which is top to down and there is no going back to the previous stage. This approach, however, had a lot of issues. For example, you start with one step and then you cannot go over to another step until the previous step is completed, or you cannot move back to any previous step, just like how waterfall works, one step to another, top to down. And there were a lot of other issues with this traditional workflow, such as it was time consuming as you deliver the entire application at once, and a long delivery time to make any fixes. It was unproductive as you cannot go backward and different teams dependent on each other to complete their task. For example, testing cannot be started without the entire code is developed. Deployment team cannot do anything without the entire code base is tested by the testing team and so on. So there were a lot of dependencies between each of these steps. Changes were costly as you have to follow the entire life cycle for a change, and there were lack of transparency as the customer involvement is limited. There were also management bottlenecks as there is no scope to pivot or prioritize the task, and everyone was sticking to the process. Well, results: unhappy customer, over budget issues, burned out team with a lot of work, long delivery time, or in making the changes. Well, to fix the issue with the waterfall model, a lot of advanced models were developed, such as RAD, Rapid Application Development, and there were many more. One of the most successful model that we follow these days is Agile. It follows the similar step with a mindset of improvement in each step. How can we do better each time? Basically, it works on the philosophy of continuous feedback at all the stages. Instead of delivering everything at once, we deliver the product in small iterations. So, even if your requirement changes or any new bugs come up or any new feature that needs to be implemented on priority, you can basically follow the same process and complete the priority item in the next iteration and so on. Result: happy customer, less time to market, more cost effective, team is happy, customer is happy, product delivery is on time. You can make the changes, you can prioritize the changes as per your priority. But this was agile. So, what exactly is DevOps and what problem does it solve? Let's have a look. So, you might have seen a similar image multiple times already. So, I will just spend a few minutes on this. Basically, DevOps solved the similar problem of traditional software development lifecycle, but Agile was limited to development of the application or the software. With the introduction of DevOps, it extends this to operation and production by bringing teams together and implementing the automation, monitoring, and feedback at all the steps in development lifecycle. So basically, it starts with planning, right? Then coding, then building your code, packaging it, compiling it, testing it. From planning to test, this is what's been referred as CI or continuous integration. Then release, deploy. These two stages been referred as CD, which is continuous deployment, and then finally operate and monitor, which comes under continuous monitoring. Why we are saying continuous in each of these group of stages? Because you see it's been referred as infinity, and we are showing that this is an ongoing and continuous process from one stage to another, right? With the help of DevOps, we bring teams together. So that is why, Dev and Ops plays an important role. But it's not just developer and operations team. There are different other teams as well, such as, your security team, your business, your QA team or testing team. So these teams also plays an important part in the DevOps lifecycle, because as part of this particular CI/CD process, we will also be doing continuous testing. So we might need help and support from testing team, or testing team will be helping us out in creating the test cases or maybe automating those. The same way, we will be doing a lot of vulnerability scanning or container image scanning, and all those we will be doing with the help of security team. And business will also provide the requirement and other different aspects of our SDLC. That is why it is not just a combination of developers and operations. This entire life cycle brings every team together so that we can work together without being in silo and achieve the organizational goal effectively and efficiently. Now we have covered till here. Okay. Now let's go to the next topic, which is Azure DevOps. So what you can do is you can go to this particular URL. Again, link is there in the day 1 folder itself and all the other steps as well. So you can go to this particular link and then click over here, which says start free. Once you click over there, it will ask you to do the sign up. Once you do the sign up, you will be redirected to this particular URL, dev.azure.com. And this is the default organization that it creates for you, right? So on the left side, this is the organization and then a test project. So you can have multiple organizations created and you can have multiple projects created inside these organizations. So these organizations are logically separated. That means resources from one organization cannot access the resources of other organization unless the explicit access has been provided. We'll see later on in the course how we can do that. But for now, just understand they are logically separated. For example, you're working for a bank. A bank might have different line of businesses such as retail banking, commercial banking, foreign exchange, and so on. So you could have a separate organization created for each line of business because they are separate entity, although within the same parent organization, right? So that's how you can separate those resources with the help of an organization. And within the organization, you can create different projects for, let's say, for dev, test, prod, or within the different teams as well, or you can divide based on the application as well. So it totally depends on the hierarchy structure that you are planning to follow. As I said, on the left side, this is the default organization that's been created. You can create a new organization by clicking over here, and there are settings that's been applied at organization level and the project level as well. So to check the organization level setting, you go to a bottom left corner which says organization setting, click over there, and all the settings will be present over here, right? which is applied at the organization level. We'll see each of these in detail in the upcoming course. But for now, just understand this is how we maintain and manage organizational settings. Now I can go back and I can go inside the project by clicking over here, or on the right side, I can click over here to create a new project. Right? Let's create a new project. I'll name it Day-1 project because this is Day-1 demo, right? You can choose this to be a public project. That means it can be accessed by anyone over the internet, just like a public GitHub repository, or you can make it as a private. Default is private. So this is what I will go with, right? And if you hit advanced, it will just ask you default options such as the type of version control that you want to use, whether Git based or TFVC. I will also explain these two in the third day, right? But for now, like these two options that it provides you, and then different work item process, like whether you want to go with Agile, Basic, CMMI, or Scrum, right? So you can select your work item process. These are just nothing but the project management framework that you can choose from. So once you verify all the details, you can hit create, and the project is created for you, which is similar to the test project that we had, right? On the bottom left side, you will see the project setting similar to organization setting, but now this is just for the project only, and it doesn't have to do anything with the organization, right? So you click over there, and the similar view that organization has, it will have sort of similar view. Not everything is same, but sort of similar view for the project setting as well. Right? Now you can go back to the project from here. Okay, I'll click over here. Now let's see what all the different options are. So first is the overview, which is this page. This is a sort of dashboard that we can set. It will have project stat and some other widgets, including the members. Currently, I am the only member in this project. Then we have dashboard. These dashboards are nothing but the widgets that you configure and that you want to have a quick overview of the project with, right? Then we have wiki. So if you have worked with Confluence before, this is just this is similar to that, in which you can collaborate with your other team members and create your documents that you want to share across the project, right? So this is what it is. Then we have boards. Project board is similar to Jira, which is also a project management tool. Here we create work items, we track our progress, we usually have stand-ups in which we discuss the progress, blockers, and update all the progress over here. Right? We'll see that in the day 2 video. Then we have repos. So repos is nothing but, as the name suggests, it's a repo. What we have selected while creating the project, we selected it to be a Git based repo. So that is what it is showing right now. So you can create a new repository inside it and you can start working with it. You can create multiple repositories. The next is pipeline. Right, once you click on the pipeline, there are two type of pipelines. First is the build pipeline, which is CI, and the another one is a release pipeline, which is your CD pipeline, right? So we will use those as well in the upcoming course. Then we have test plans. Basically, this is the service to perform testing in Azure DevOps. Then we have artifacts. Artifacts is nothing but an artifact repository such as Nexus or JFrog Artifactory. We can create our packages after the build has been compiled, and we can store the packages over here in this artifact repository, and then we can use those in the release pipeline to deploy the same packages in different environments. So this is just a quick overview of what Azure DevOps is. It's nothing but, if you go to any of the project, it's nothing but a set of tools that helps you solve all the traditional development lifecycle processes with the modern processes and tools. You don't have to worry about integrating it with the different tools such as Artifactory or GitHub. Everything is integrated in one single tool, the way that we have just seen. There are two type of hosting solutions for Azure DevOps. First one is Azure DevOps Services, which is cloud offering, which is what we are using and what we have just seen. Then we have Azure DevOps Server, which is nothing but an on premises implementation of Azure DevOps on your own data center, right? Let's have a look at the pricing of each of those. The first one, Azure DevOps Services. If we see for the license, we have a basic plan, which is what we are using. In this basic plan, we have 5 free users. That means, along with my default user, I can create 4 more users, which will be free of cost. And any additional user on top of those 5 users will be $6 per user per month, right? So 5 users should be more than enough for us to complete this entire course. So you don't have to worry anything about costing. It also says, like, if you want to use the test plan, there is a upgraded license which is $52 per user per month, but there is a 30-day free trial. So this is what we'll be using, right? um there are some service level limits as well. So if you go on the left, you see one free hosted Microsoft hosted CI/CD agent and one free self hosted agent. We'll see what that is. And 2 gigabytes of Azure Artifact storage, but 2 GB is more than enough for us. And then after that, it will be charged $2 per GB. So this is the pricing and some limitations based on the plan that you are using. So it will be mostly free for us. If you scroll down and it says Azure DevOps is included with Visual Studio subscription. So if you are part of any organization that has Visual Studio subscription, then you can access it for free, and there is no limit to the number of organizations that you create, and that doesn't count against your 5 user limit, right? So you can start using it for free without any restrictions if you are a Visual Studio subscriber. All right, so that's it for this video. I hope this video was somewhat helpful in understanding the basic concepts of DevOps, Agile, CI/CD, and Azure DevOps. In day 2, we'll be looking into Azure boards, work items, and everything that is there in the GitHub repository. So let me know if you have any questions related to this video, or you can ask your question in our Discord community as well. All the links are provided in the GitHub repository. So feel free to check that out. And I will see you tomorrow. And I hope you have a good day. I hope you had a good learning.